Time. It's the silent rhythm that underlies every moment of our lives, the invisible thread weaving together our memories, our hopes, and our dreams. From the instant we are born, time becomes our constant companion, quietly marking the chapters of our existence. It's the one thing we all have in equal measure. No matter who we are, where we come from, or what we believe, each of us is given the same 24 hours in a day. Time is the great equalizer, connecting us across cultures, generations, and continents. Every second that ticks by is a shared experience, a reminder of the precious and fleeting nature of existence. The gentle sweep of a clock's hand, the soft fall of sand in an hourglass, these are the subtle signals that life is always moving forward, never pausing, never rewinding. Yet for all its familiarity, time remains one of the most profound mysteries in the universe. What exactly is time? Is it a physical dimension like space, or merely a construct of our minds to make sense of change and motion? Why does it seem to flow in one direction? Why do we remember the past but not the future? The river of time carries us ever onward, and we can only look back at the shores we've already passed. And is it possible to manipulate its fabric? To journey through its corridors to the past or future? Could we ever step outside the relentless march of seconds and minutes and glimpse what lies ahead or behind? For centuries, philosophers, scientists, and storytellers have wondered, can we break free from time's grip? The idea of time travel has captured our imagination, inspiring countless tales and theories. We experience time in a linear way. Yesterday is gone, tomorrow is yet to come. We live in the present moment, a constantly shifting point between what was and what will be. Our lives are a collection of moments, each one slipping into memory as the next arrives. But what if this perception of time is merely an illusion, a limitation of our human experience? Could reality be far stranger than we imagine, with time existing all at once, past, present, and future layered together? Imagine for a moment the vastness of the cosmos. Out there, time stretches and bends in ways that defy our everyday understanding. The universe is a stage where time plays out its most dramatic acts. Billions of galaxies spread across unimaginable distances. Each one is a cosmic clock, ticking at its own pace, shaped by gravity, energy, and the mysterious forces that govern the universe. Stars born and dying in spectacular celestial displays, their lifespans stretch across millions, even billions of years, reminding us how brief our own time truly is. Black holes, where time and space themselves are warped beyond recognition. Near these cosmic giants, time slows to a crawl, and the rules we know begin to break down. Einstein showed us that time is not absolute. It can stretch and compress, depending on speed and gravity. The deeper we look, the stranger time becomes. In the grand cosmic ballet, our human understanding of time might be just a tiny step in a much grander dance. We are participants in a story that began long before us and will continue long after. Could we one day unlock the secrets of time? Could we learn to read its patterns, to understand its true nature, and perhaps even to master it? Could we build a vessel to carry us through its currents? The dream of traveling through time, of exploring history or glimpsing the future, continues to inspire our greatest minds. The very idea sparks our imagination and beckons us to explore the unknown. Time is both our constant companion and our greatest enigma, a puzzle that invites us to keep searching, questioning, and dreaming. To grasp the possibilities of time travel, we must first venture into the fascinating and sometimes bewildering realm of modern physics. This is a world where the rules we take for granted in our everyday lives are turned upside down, and where the very fabric of reality is revealed to be far stranger than we ever imagined. Our guide on this journey is none other than Albert Einstein, a name synonymous with genius and revolutionary thinking. Einstein's insights didn't just change physics, they transformed our understanding of the universe itself. His theory of relativity, unveiled in the early 20th century, became a cornerstone of modern science. It fundamentally altered how we perceive time, space, and the relationship between them. Before Einstein, time was thought to be absolute, a steady, unchanging river flowing at the same rate for everyone, everywhere. But Einstein shattered this notion. He taught us that time is not absolute. It is not a universal clock ticking at the same rate for everyone, everywhere. Instead, time can stretch and shrink, depending on where you are and how fast you're moving. According to Einstein, time is relative. It is intimately woven together with space to form a four-dimensional fabric known as space-time. This concept is at the heart of his revolutionary ideas. And this fabric, much like a flexible sheet, can be bent, stretched, and warped by the presence of mass and energy. Gravity, in Einstein's view, is not just a force pulling objects together, it is the result of massive objects curving the spacetime around them. To visualize this, picture a heavy bowling ball placed on a trampoline. The ball creates a dip, a curvature in the fabric. Smaller objects placed nearby will roll toward the ball, not because they are being pulled by an invisible force, but because the fabric itself is curved. That curvature is akin to gravity's effect on spacetime. The more massive the object, the deeper and more pronounced the curve becomes, influencing the paths of anything moving nearby, including light and crucially the passage of time itself. The more massive an object, the more it distorts the fabric of spacetime, and consequently, the more it affects the flow of time nearby. This means that time itself can slow down or speed up depending on the strength of gravity in a given location. This leads to a truly astonishing consequence. Time passes slightly slower near objects with strong gravitational pull, like black holes or even the surface of our own planet, compared to regions of weaker gravity, such as high mountain peaks or deep space. It's a mind-bending concept, but one that has been confirmed by rigorous experiments and careful observation. Scientists have tested Einstein's predictions using some of the most precise instruments ever built. Atomic clocks, which are among the most accurate timekeepers in existence, have shown that clocks tick ever so slightly slower at sea level, where Earth's gravity is stronger than they do at higher altitudes. Even a difference of a few meters in height can be measured with these remarkable devices. Einstein's theory of relativity doesn't just explain the universe, it opens up the tantalizing possibility that, if we could somehow manipulate gravity or the fabric of space-time itself, we might one day learn to manipulate time. The dream of time travel, once confined to the pages of science fiction, now stands on the threshold of scientific possibility, thanks to the revolutionary ideas of Albert Einstein. If spacetime is a fabric that can be bent and stretched, then the universe itself is far more flexible and dynamic than we might first imagine. This concept, which lies at the heart of Einstein's general theory of relativity, suggests that the very structure of reality is not fixed but can be warped by the presence of mass and energy. Gravity, in this view, is not simply a force pulling objects together, but rather the result of massive objects curving the fabric of spacetime itself. This opens up a fascinating question. If we can bend spacetime, could we also manipulate it in even more dramatic ways? Could we fold it in such a way to create shortcuts between distant points in spacetime? Imagine being able to travel from one side of the galaxy to the other in the blink of an eye, not by moving faster than light but by taking a hidden path through the universe itself. This idea, while it sounds like pure science fiction, is actually rooted in real physics. This is the enticing idea behind wormholes, theoretical tunnels that could connect not only different regions of space but different points in time as well. Wormholes, sometimes called Einstein-Rosen bridges, are solutions to the equations of general relativity that act as shortcuts through the fabric of spacetime. If such structures exist, they could, in theory, allow for instantaneous travel across vast cosmic distances, or even open the door to time travel. Imagine a piece of paper representing spacetime. On this paper, 2 points might be separated by a great distance if you travel along the surface. But what if you could fold the paper, bringing those 2 points together? A wormhole would be like folding that paper so that 2 distant points touch. Instead of traveling the long way across the surface, you could simply step from one point to the other through the shortcut created by the fold. This analogy helps us visualize how a wormhole could connect 2 far-flung regions of the universe, making the impossible seem almost within reach. A traveler could then instantly journey between those points, bypassing the vast expanse of space-time that separates them. The journey that would take thousands or even millions of years at the speed of light could, in theory, be completed in a matter of moments. This concept has inspired countless works of science fiction, but it also raises profound questions about the nature of reality, causality, and the limits of human exploration. While wormholes remain firmly in the realm of theoretical physics, their existence has not been ruled out by our current understanding of the universe. Scientists continue to explore the mathematics of these exotic structures, searching for clues that might reveal whether they could ever exist in reality, or if they are destined to remain a tantalizing possibility. They emerge as solutions to Einstein's equations, suggesting that the fabric of space-time might be even stranger and more malleable than we can currently imagine. However, creating or stabilizing a wormhole would likely require forms of matter and energy that we have yet to discover, such as so-called exotic matter, with negative energy density. The search for such materials is ongoing and remains one of the great challenges in modern physics. Another intriguing concept is warp drive, a hypothetical technology that could allow a spacecraft to travel faster than light, not by exceeding the speed limit of light itself, but by distorting space-time around the craft. The most famous version of this idea is the Alcubierre drive, which proposes compressing space in front of a ship and expanding it behind, effectively moving the ship without it ever locally breaking the cosmic speed limit. The spacecraft would essentially ride a wave of compressed space-time, like a surfer riding a wave on the ocean. In this scenario, the ship itself remains stationary within its own bubble of normal space while the bubble moves through space-time at incredible speeds. This would allow for interstellar journeys that would otherwise be impossible within a human lifetime. While the technological hurdles to creating wormholes or warp drives are immense, perhaps insurmountable, the very fact that such concepts arise from our current understanding of physics is a testament to the extraordinary possibilities that the universe might hold. As we continue to probe the mysteries of space-time, we may one day discover that the shortcuts and wonders imagined by science fiction are not so far-fetched after all. The universe, it seems, is full of surprises, waiting for us to unlock its deepest secrets. The dream of time travel has long captivated the human imagination, fueling countless stories, films, and works of art. From H.G. Wells's groundbreaking novel The Time Machine to the epic adventures of Doctor Who and the mind-bending paradoxes of Back to the Future, time travel has become a staple of science fiction, allowing us to explore the boundaries of time and the consequences of altering the past or future. Fiction often uses time travel as a vehicle to examine our relationship with the past, our hopes and anxieties about the future, and the very essence of free will. It allows us to ask what-if questions, to imagine alternative timelines, and to contemplate the ripple effects of our actions across time. These stories, while often fantastical, can serve as thought experiments, prompting us to consider the philosophical and ethical implications of time travel. What would it mean to meet our past selves? Could we change the past without unraveling the present? And what responsibility comes with the power to influence the course of history? While fiction might take creative liberties with the science of time travel, it often draws inspiration from real scientific concepts, blurring the lines between what is possible and what might one day become reality.